Good morning, children. Today we are going to do the revision of chapter number 1, that is rational number. Now, first of all, we are going to learn what is rational number. The numbers of the form a by b, where a and b are integers and b is not equals to 0, are called rational numbers. Let us take some examples. Now, 5 by 8, minus 3 by 14, 7 by minus 15 and minus 6 by minus 11 is a rational number. Now, rational numbers are of two types. First one is positive rational numbers. Second is negative rational numbers. Let us see what is positive rational number. A rational number is said to be positive if its numerator and denominator are either both positive or both negative. Let us take examples. 5 by 7 and minus 2 by minus 3 are both positive rationals. Now, negative rational numbers. A rational numbers is said to be negative if its numerator and denominator are of opposite sign. Thus, minus 4 by 9 and 5 by minus 12 are both negative rationals. Now we are going to learn how to compare a rational number. Now all of you remember one thing, that every positive rational number is greater than 0 and every negative rational number is less than 0. Now there is one general method of comparing rational numbers. There are few steps. Let us see. The first step is express each of the two given rational numbers with positive denominators. Step number 2 is take the LCM of these positive denominators. Step number 3 is express each rational number with this LCM as the common denominator. Step 4 is the number having the greater numerator is greater. Let's take one example. Suppose we want to find 3 by minus 4 and minus 5 by 6, which is greater. Now first we write each of the given numbers with the positive denominator. It means 3 by minus 4 will become minus 3 by 4. This we will get by multiplying the numerator and denominator by minus 1 and minus 1. The other number is minus 5 by 6. Now we will have to find the LCM of 4 and 6, that is 12. So minus 3 should be multiplied by 3 and 4 also should be multiplied by 3. Now it will become minus 9 by 12 and minus 5 by 6, it should be multiplied by 2 and 2. So it will be minus 5 multiplied by 2, it will be minus 10 and 6 multiplied by 2, it will be 12. Now all of you can see that minus 9 is greater than minus 10. So minus 9 by 12 is greater than minus 10 by 12. Now we are going to learn how to represent a rational number on the real line. In the previous class we have learned how to represent integers on the number line. Now let us review it. Now what we will have to do, first of all, draw a line. Then take a point O on it, call it 0 also. Set off equal distances on the right as well as on the left of 0. Such a distance is known as unit length. Now clearly the point A, B, C, D and E represent the integers 1, 2, 3, 4 and 5 respectively, and the points A dash, B dash, C dash, D dash and E dash represent the integers minus 1, minus 2, minus 3 and minus 5 respectively. Now thus we may represent any rational number or any integer by a point on the number line. Clearly every positive integer lies to the right of 0 and every negative integer lies to the left of 0. Now similarly we can represent the rational number also. Let us take one example how to represent rational number on a number line. Suppose we want to represent 1 by 2 and minus 1 by 2 on the number line. Now the steps will be like this. First of all, draw a line, then take a point 0 on it, let it be O, and then set off unit lengths OA and OA dash to the right as well as to the left of this 0. Then A represents the integer 1 and A dash represents the integer minus 1. Now divide OA into two equal parts. Let OP be the first part out of these two parts. Then the point P represents the rational number 1 by 2. Again, divide OA dash into two equal parts. Let OP dash be the first part out of these two parts. Then point P dash represents the rational number 1 by 2. Is it clear? Now we will learn about negative of a number. Now while studying integers, you have come across negatives of integers. Now what is the negative of 1? It is minus 1, because 1 plus minus 1 equals to minus 1 plus 1, that is 0. So what will be the negative of minus 1? So it will be 1. Also 2 plus minus 2 is equals to minus 2 plus 2, that is 0. So we say 2 is the negative or additive inverse of minus 2, vice versa. In general, for our integer a, we have a plus minus a equals to minus a plus a, that is equals to 0. So a is the negative of minus a and minus a is the negative of a. Now for the rational number 2 by 3, we have 2 by 3 plus minus 2 by 3 equals to 2 plus minus 2 by 3, that is equals to 0. It means the additive inverse means if it is positive number, then it will be negative, and if it is negative, it will become positive. That is called additive inverse. Now children, we are going to learn about reciprocal. Now by which rational number would you multiply 8 by 21 to get the product 1? Obviously by 21 by 8, since 8 by 21 into 21 by 8 is equals to 1. Now similarly, minus 5 by 7 must be multiplied by 7 by minus 5 so as to get the product 1. Is it clear? Now here be careful one thing, that minus 5 is there, and when we are writing the reciprocal, minus 5 is coming down. Is it clear? Now so say that 21 by 8 is the reciprocal of 8 by 21, and 7 by minus 5 is the reciprocal of minus 5 by 7. Now can you say what is the reciprocal of 0? Is there? No. Is there a rational number which when multiplied by 0 gives 1? No. So thus 0 has no reciprocal. Now we say that a rational number c by d is called the reciprocal or multiplicative inverse of another rational number a by b if a by b into c by d is equals to 1. Now children, here you can understand that what is the difference between additive inverse and multiplicative inverse. In additive inverse, we change the sign, means if it is plus, it becomes minus, and if it is minus, it becomes plus. But in reciprocal or multiplicative inverse, the numerator becomes denominator and the denominator becomes numerator. This is the difference between additive inverse and multiplicative inverse. Now one more thing, that in multiplicative inverse we don't change the sign, means if it is negative, it remains negative, because we are just writing the reciprocal. We are not converting the positive into negative or negative into positive. We are just writing the reciprocal. The numerator is becoming denominator and the denominator is becoming the numerator. But when we write additive inverse, then we change the sign. If it is positive, it becomes negative. If it is negative, it becomes positive. Is it clear? Now we have revised each and everything of rational number. Now today I am going to give you one revision work which you will have to do and send it to me. Okay, thank you.